Up until now, we have seen how we can use or target each and every element in our HTML, how we can source our external CSS files, inline styles, attribute level styles, internal styles, how we can, what are the different types of selectors that we can make use of in our CSS. We also looked into the difference between a display none and visibility hidden or opacity 0. We also looked into CSS sprites, image sprites, where we can use a single image and by the help of background, we can basically choose or pick one section inside that image and show it to the user. Now we are going to look into one of the coolest feature of all, and that is the animations. CSS animations. Animations in CSS. Before we jump into that, we need to first understand how browsers understand these animations, or why a browser understands the math behind this animation and then performs its own animation, whatever the logic that we're going to say. Like for example, on hover of an element, I want to move that element some 20 pixels in the X direction, right? So how the browser, so the standard thumb rule is this, that when you're looking into the browser, right, this is the X direction and this is the Y direction, right? So this is the Y direction and this is the X direction. We already looked into Z by adding the Z index. Animating the Z index is kind of not possible because browsers, they don't understand that. They only understand the X and Y directions. We can try to perform some of the actions in the Z direction, but the Z index is something we cannot animate. Okay, so how the browsers understand all these animations? When the first browser came in, the very first browser was Internet Explorer and Netscape. There was a browser called Netscape. These two browsers, they simply cannot, they did not understand the animations up until the evolution where CSS functions were introduced. Okay, I don't see, where is that? Where is that? CSS functions. Come on. Okay, this up until now we have seen that how CSS work is that you select or target an element, you basically add your styles. That's it. But and this trend was still CSS 1 and and CSS, some part of the CSS 2. In CSS 2, they introduced this functions kind of concept where you can execute an entire function like a JavaScript function inside your CSS. So the browsers like Internet Explorer and then Netscape, these guys, they did not understand these functions. Their understanding was simply target the element and apply styles. So that's why when you go back to a website which is like back in 1995 or 96, and in that era, you will not see you know good animation going on. The best animation they could come up with was Marquee, right? And the Marquee used to look something like this. I don't know if I can, well, if I can show you a demo. Here's the demo. Come on. Okay. This is the best animation they could do back in 1990s. Yeah, this is the best animation they could do back in 1990s. And this is called as Marquee, right? So up until then, this was the only animation that any website could do in using in IE and Netscape browsers. Slowly, when Firefox, Opera, and then Chrome, Safari, all these browsers came into picture, right? So we got Internet Explorer, right? Internet Explorer. From this point, I'll be calling it as IE. Then there was Opera. It's Opera IE. This is Opera, and then came the Firefox. Then came Chrome. Then came Safari, and there are other browsers, but these are the main ones, right? And what do I mean by main ones? Okay, there are four major web engines. Okay, web engines, or we can say browser engines. These these engines are basically the brains behind the browser, right? So how will my browser understand, like, what is it is the brain, it is the engine is the main brain behind any browser. Whenever you enter google.com URL, it is the engine behind the browser which says, okay, create a tunnel, make a connection, download all the files, put it in the cache, then render that image, look for that HTML file. If that HTML file has CSS linked to it, then look for CSS file. All of that functionality, all of that is what this web engine is going to do. Okay. And as I said, there are four main web engines. One is the WebKit. Okay. Second one is the Mozilla. This is one of the web engines. Next is the Opera itself. And then finally, we got the Internet Explorer. Okay. Internet Explorer is not called as IE. It is more of called as MS, Microsoft. Let me say like this. Okay. I'm going to say like this. Okay. These are the engines, but these are called as WebKit is called as WebKit. Mozilla is called as Mozilla. Opera is also called as Opera. But IE is called as Microsoft. Okay. The code name, okay, code name for WebKit is dash WebKit. The code name for Mozilla is dash MOZ. The code name for Opera is -O, and then finally we got Microsoft, and the code name is MS. Okay, there are major 4 web engines. Okay, major ones are 4 up until now. Okay, up until now there are only 4 main browser engines. One is the WebKit, next is the Mozilla, the next one is Opera, and finally the Internet Explorer, which is the Microsoft, you can say, right? All the versions of IEs, they use the MS code name. Okay, Opera's, all the versions of Opera's is O, the code name. Mozilla is MOZ, and WebKit is called as WebKit. Okay, Safari and Chrome follow WebKit engine. Okay, Firefox follow MOZ engine. Okay, Opera is, well, Opera follows -O engine, and then finally IE follow -MS engine. So there are certain functions, okay, there are certain CSS functions that we need to target, based upon specific browser engines. Like for example, if I simply say border, or let me say border color. Okay, let's assume that border color is like a special style. Let's assume, right? If you simply say border color red, something like that, we need to make sure that it is supported in all the engines. Okay, and chances are we need to specify like this for WebKit. Okay, for Mozilla you need to say MOZ hyphen border color red, and then border color red. Finally we need to say MS border color red. So not only I'm writing styles for each and every browser engine, I'm also writing a fallback. Like if any of these fail in the browser that you are using, then there is a default border color also, so that my style is not going to break. Right? Now the question is which styles, alright? This question is which CSS style is specific to WebKit, right? There are certain rules that people follow that you simply, like, not all of the styles have this, right? So we are not sure, right? Because well, how should I say it? How should I say it? The CSS guys, they try to keep things as modular as possible. When I say modular, mean you don't need to write a WebKit specific style, or you don't need to write MOZ specific styles, right? You can simply say border color, and all the browsers will try to understand it. So that is the modular way of styling. But there are certain styles. Moving forward, we are going to see the responsiveness, and responsiveness is something is browser specific. So there are certain styles which are specific to WebKits. There are going to be some certain styles specific to Mozilla thingy. So The question is, I mean, if you ask me any question saying that, you know, if what are the styles which I want to target only for WebKits, I may not be able to give you the right answer, because as I said, the CSS guys, they are trying their best to modular the entire CSS in such a way that you don't need to clear specifically say, like, you know, WebKit border color or WebKit or Mozilla border color. You simply say border color and it will take it. All the browsers will understand. They're trying to keep that as much as modular as possible. But yet there are certain styles that are not going to work ideally like this. And those styles are what the animations are. Animations behave differently uh, differently in different web engines. So we need to specify engine specific animation style. Okay, and now we are going to look. So what I'm trying to say is, when you're writing the general styles like border or background or anything, you don't need to write engine specific styles. If you simply say border color, all the browsers will take it. But when it comes to animation or moving forward, this responsive web designing, we need to be writing browser engine specific styles, because styles is an exception, because styles is going to execute some functions, right? It's going to execute these kind of functions. And what are functions is, what functions are basically told, like given like this: calculate 100% and then reduce 100 pixels from it. So like if my screen size is 1500 pixels, that is 100%. Reduce 100 from it, then it's going to be 1400 pixels, right? So it is this, the width is going to be calculated like this. So whatever the width here is minus 100 pixels. So if you see this, it is always going to be the equal amount, right? So this is how the calculations is going to perform. So there are other functions kind of like this, right? And then animations is going to follow these kind of calculations or functions callback, right? So animations behave differently in different web engines. So we need to target each web engine to write the styles for that. So let's come back to our example. Let me copy this guy, paste it, and today's date is 26th. Okay, yep. And then let me open up in this Chrome. Okay. Now let's say that when I hover over this div new license permit, okay, if I say div license permit, when I hover over it, I want to move this guy. Either I can move it in the up direction or in the right left direction, right? I can go in either y direction, so meaning I can move it positive y or negative y, right? I can move it in positive y direction or negative y direction, or I can go in positive x direction and negative x direction, right? We will look into Z when we are dealing with 3D animations. Right now we are just dealing with 2D animations. So again, animations are of two types, okay? 2D animations and 3D animations. So let me say like this. Okay, there are two types of animations. One is 2D and the second one is 3D. 2D animations, or in CSS world it is called as transform, 2D transform. Okay, 2D transforms or 2D animations or whatever you call it. Um, we can uh, we can perform the following actions. First one is translate. Translate means moving. I can translate, meaning moving the element in x axis or y axis. Okay, so you can translate means moving in x axis or y axis. Second one is rotate. Rotating in clockwise or counter clockwise direction. Okay, next is scale. Increase or decrease the size of the element. And then finally there is something called as skew. uh, Sorry. Skew means, how should I say it? I can show you an example because I cannot explain it to you. The skew mechanism. Go back. Go back. 2D transform. Okay. Skew. This is skew. Like how should I say it? Like if I change this to 30 degrees, and then 30 degrees. Are you able to make out, guys? Or if I want to change it to 10 degrees, for example, 10 degrees, 10 degrees, right? What should I show you? Skew animation, let's say. Come on, no, skews. Yeah, this is skew. Can you see this? This is skewing. I don't know how do I explain it to you. Rotate means it will simply rotate the, like, it is going to go circle. That is what rotating means. Translation means moving it left and right or up and down, right? Scale means the size is going to be increased. Skewing is basically like a tilt mechanism, or you can say a stretching mechanism. You can stretch it in both x direction and y direction, or you can do only in one direction. In this example, he's doing in both x and y directions. If you simply say 0 directions in the y, then you will see only in the x. If I simply increase it to 100 degrees in the x direction, this is how the skewing, it's like stretching the element in both x and y, in both the x directions and y directions. So that is what the skewing means. It's like stretching the element in x axis and or y axis. నేను మళ్ళీ రిపీట్ చేస్తున్నా. మొదటికి వచ్చేసి అంటే పాతప కాలంలో ఒకటే ఒక బ్రౌజర్ ఉండే ఐ, దాంతోపాటు ఇంకొక బ్రౌజర్ ఉండే నెట్స్కేప్ అని. నెట్స్కేప్ ఎప్పుడో బంద్ అయిపోయింది. నో వన్ యూజెస్ నెట్స్కేప్ ఎనీమోర్. ఓకే, సో పాత టైంలో మనకి యానిమేషన్స్ అంటూ ఉండదు, లేదు, ఎందుకంటే మన ఈ సిఎస్ఎస్ ఫంక్షన్స్ ఇంట్రడ్యూస్ చేయలేదు వాళ్ళు. వెన్ CSS2 came into picture, right now we are dealing with CSS3. Okay, so when CSS2 was introduced, at that time functions were introduced, CSS functions. And what are functions is basically the math function or the attribute function, which we can pass the arguments and then it's going to compute the outcome and it's going to show us the result. When these functions were introduced, slowly the browsers, they started understanding these functions and started to execute the function callbacks. Now, and over the time being, in the simultaneous world, the companies like Google, Mozilla, this Opera, these guys, they came up with their own web engines. వెబ్ ఇంజిన్ అంటే ఏంటంటే బేసిక్లీ మన బ్రౌజర్ కి బ్రెయిన్స్ అన్నమాట. ఇప్పుడు నేను ఒకసారి ఏంటి ఈ బటన్ ని క్లిక్ చేస్తున్నానంటే ఏం యాక్షన్ చేయాలి అది ఎవరు చెప్తారు? ఈ వెబ్ ఇంజిన్స్ చెప్తారు. వెబ్ ఇంజిన్స్ వచ్చేసి ఓకే, నౌ ఐ హావ్ టు perform this action, now I have to contact google.com and get the files. All that brains is taken care by the web engine. Okay, so ప్రస్తుతం ఉన్న వరల్డ్ లో there are only like 4 main web engines. ఒకటి వచ్చేసి మనకి WebKit. WebKit was first developed by this guy, Google guys. Okay, then Mozilla, next వచ్చేసి Opera, and then finally మనకి ఇంటర్నెట్ ఎక్స్ప్లోరర్ అంటే మైక్రోసాఫ్ట్ వాళ్ళు. మన బ్రౌజర్ లో వచ్చేసి వాళ్ళకి ఈచ్ వెబ్ ఇంజిన్స్ కి ఒక కోడ్ నేమ్ ఇచ్చింది, అండ్ దట్ ఈస్ -WebKit, -MOZ, -O for Opera, and then -MS for Microsoft. Browsers, Safari, Chrome Canary, all these browsers, they support WebKit engines, right? Firefox follows the MOZ engine. Opera follows the Opera Opera engine. This is O, not 0. And then IE follows the MS engine. Okay. యానిమేషన్స్ లో వచ్చేసి ఏంటంటే ఇప్పటి వరకు మనం చూసిన అన్ని స్టైల్స్ లో ఏంటంటే మీరు ఒక ఎలిమెంట్ ని టార్గెట్ చేస్తున్నారు, దానికి మీరు ఏదో స్టైల్స్ ఇచ్చేస్తున్నారంటే బ్యాక్గ్రౌండ్ కలర్ అనుకోండి, లేకపోతే బార్డర్ కలర్ అనుకోండి, వాట్ ఎవర్. బట్ వెన్ ఇట్ కమ్స్ టు animations are functions. Okay, these are functions, and basically the functions take some arguments and then the browser's web engine understands those functions and then it gives out the result. Okay, అందుకే కొన్ని బ్రౌజర్స్ వేరే విధంగా పనిచేస్తాయి, వేరే బ్రౌజర్స్ వేరేగా బిహేవ్ చేస్తాయి. సో అందుకే వెన్ ఇట్ కమ్స్ టు యానిమేషన్స్ మనం బ్రౌజర్ స్పెసిఫిక్ యానిమేషన్స్ రాస్తాం. ఉత్తి జనరల్ స్టైల్స్ ఎట్లా రాస్తాం అట్లా రాయకుండా మనం బ్రౌజర్ స్పెసిఫిక్ స్టైల్స్ కూడా రాస్తాం. A good example is behind this notepad. You see the skew, it is a function. Okay, మనం ఆ వెబ్సైట్ స్పెసిఫిక్ స్టైల్స్ రాస్తాం. ओके, 4 किस्म के वेब इंजिन्स हैं: वेबकिट, मोजिला, ओपेरा, माइक्रोसॉफ्ट. कोड नेम्स है MOZOMS एंड देन वेबकिट. ठीक है, इंटरव्यू में पूछ सकते हैं आपको कि भाई tell me what are the different web engines that you have worked with, and your answer should be, well, I mostly deal with WebKit and Mozilla, but I do know how Opera and IE engines work. Right? Safari और Chrome WebKit follow करते हैं, Firefox MOZ engine follow करते हैं, Opera O, and finally IE follows MS, Microsoft engine. अब एनिमेशंस आते हैं, जब हम लोग एनिमेशंस बोलते हैं तो क्या होता है कि ये जो एनिमेशंस है ये रेगुलर स्टाइल्स नहीं है, ये फंक्शंस हैं. सो ये फंक्शंस जो है, अभी वेब इंजन, एक वेब इंजन जो है एक हिसाब से उस फंक्शन को समझेगा, दूसरा वेब इंजन एक और तरीके से समझेगा. सो इसके लिए व्हेन इट कम्स टू एनिमेशंस हमको ब्राउजर स्पेसिफिक एनिमेशंस भी लिखने पड़ेंगे. ओके, एंड first type of styles or animation, or you can say transform, is basically 2D. 2D टाइप में आप लोग XY डायरेक्शन में ही या Y डायरेक्शन में ही मूव कर सकते हैं. दैट इज व्हाट वी कॉल इट एज ट्रांसलेट. रोटेट मीन्स घुमाना, मीन रोटेटिंग द एलिमेंट. स्केलिंग means increasing the size or decreasing the size. Skewing means it's kind of stretching in one direction, either in X direction or Y direction or both. Okay, if you combine all of these, then we call it as matrix. If we combine all the above, we use matrix. And now let's see that in action. So in my example, and why do I have it here? Close. Okay, in my example, let's say I want to move this when I hover over this element. So if I inspect element, okay, so this entire header, for example, main heading, right? When I hover over this guy, this main heading, when I hover over this guy, I want to move this guy, move down, let's say 50 pixels. Okay, so what I'll do is I'll first target, I'll go to styles.css, I'll first target that element which is main heading, right? So look for main heading, and now you need to say main heading on hover. Okay, main heading on hover should have animation move down 50 pixels, or I should say animate in 2D and translate down 50 pixels. To do that, I will say minus WebKit for WebKit, and then say minus, and then say translate. Okay. No, no, that is not the syntax. The syntax here is transform. This is the syntax. Okay, meaning I will show you. Minus WebKit, and I want to transform this element, and in this case I want to translate it, meaning I want to move. If I say scale, then I need to say WebKit transform, and instead of saying this, I would say scale. Scale, then it will increase the size or decrease the size based on whatever value I write, and I'll show you that in a minute. So WebKit transform, I want to move, and I want to move it down 50 pixels. Okay, positive value is going down. But now translate this. Translate. How should I write it? Let me write like this. Syntax is uh, transform colon translate, and then it takes x-axis, the value in x-axis first, comma y-axis. It takes both. Okay, it takes both. Now in this case, I just want to move it down. I don't want to move it on the right. So x-axis is going to be 0, and then 50 pixels down. So this is Chrome specific, or Chrome or Safari specific transform. Right? Now we need to write for Mozilla. Next we need to write for Opera, then Microsoft, and finally fallback. So this is going to be Firefox specific. Next is going to be the Opera specific. Next is going to be IE specific, and then finally the fallback. Okay, and Mozilla is MOZ, Opera is O, IE is MS, and then finally the fallback is no style, simply transform, like this. And the thing is, most in today's world, most of the browsers, they follow WebKit, like Safari and Chrome are kind of famous. So that's why that is the first style I have written. Next popular is Mozilla. Next popular is Opera. I mean, if I have to choose between Opera and Internet Explorer, I will always go with Opera. I will not go with Internet Explorer. The final one is the Internet Explorer. Internet Explorer is the least favorite of all. So if I save like this, now if I go back and if I refresh my page, I don't know, I mean, this is kind of jumping down, but you see my animation is still working. Even though my animation is not good, but let me do this. Let me increase it to 100 pixels, for example. Now, the thing is, and refresh. I don't know, like this is what the animation that is going to happen now. And the hovering is like basically, since hovering is kind of dealing with that, it is going like this, right? Similarly, let's say now for WebKit, I'm saying 100 pixels. Maybe for Firefox, you can say 50 pixels. For Opera, you may say 50 pixels. For Internet Explorer, you can say 10 pixels, right? But most of the time, your animations should be consistent regardless of what browser you are using. So that's why we use the same styles everywhere. We say 50 pixels all the way. Okay. Now that was the translation, right? Let me show you the rotation. For rotation, you simply say rotate, okay? And now rotate takes only one value. The syntax of rotate is syntax is transform and then say rotate, and you need to enter value degrees. Okay, enter the value in degrees, plus slash minus degrees. Plus means clockwise direction, negative means counter clockwise direction. Okay, and let's see that here. If I want to move this 90 degree, I'll simply say 90 degree, and then I'll copy this style everywhere. You need to be consistent, okay, because your fallback should be consistent with whatever styles you're writing. So if I save this, go back and refresh, this rotates like this, right? That is 90 degrees. If I change it to 190 degrees, for example, save it, it rotates 180 degrees, but then 10 degrees more. So makes it 190 degrees, right? And now let's say I have 90 degrees, or let's say even 60 degrees, but in negative direction, right? Minus 6, like this, minus 60 direction. Then it should go in the opposite side. It rotates in the opposite direction, counterclockwise, right? Plus means clockwise direction. It will rotate in clockwise direction. Okay, so this is the rotation. Then finally, let me show you the copy, paste, take care of that indentation. And now scale. The syntax of scale is transform colon scale, and then the value. Now the default value is 1 meaning 100%, you can say, in all directions. And if you keep on increasing it, the size is going to increase. So let me show you now how. Let me say scale, hold on, let me say right now 1, Okay, let me copy that, save it, save it, save it, and then finally save this. Okay, when I say like this, it is 1% when I hover over it, 100%. If I change this to 4, 4, 4, 4, and then 4, meaning 4 times the initial size, it will increase by 4 times. This is the 4 times of the initial scale. 1 means 100% or 1 time. 4 means 4 times, right? This is the scale in all directions. Okay. The skew, we already saw the skew in that W3 schools, but I still want to show you. The skew syntax is transform skew, first takes the x axis direction and then the y axis direction, but it takes degrees in x directions and y directions. Okay, I'll show you how, what do I mean by that. So let me say skew. I want to skew this in x direction, I don't know, 10 degrees in x direction, and then 40 degrees in y direction. Okay, again, by the way, it will also takes plus and minus. So plus means hold on, plus or minus. Plus means clockwise direction, minus means counterclockwise direction. Okay, so we're gonna see this now. Copy this guy, copy this guy. Okay, let's go back and then save it. This is how the skewing is working. If I change the y in negative, for example, okay, then your skewing will look like this. Okay, keep in mind, guys, keep in mind whatever the animation, the 2D animation that you're using, you need to use the same for all the engines. You cannot change the styles. That is the notion that you need to follow. Okay, you need to follow all the styles, meaning the same styles. Like here I'm saying skew 10 degrees and minus 40 degrees for Chrome and Safari. Then Mozilla also should follow the same style. The Opera should also follow the same style, and similarly in IE. Okay, and if all of them fail, then the fallback transform should also do the same action. Okay, remember that. Okay, ఇప్పుడు వరకు చెప్పిన కాన్సెప్ట్స్ అర్థమైందా? Did you guys understand? समझ में आ रहा है सबको? You will say transform If you simply want to transform it, like 2D means transform, okay? If you simply want to transform that, then you will say, hey, I want to use WebKit transform or Mozilla transform, Opera transform or Microsoft transform, and then rotate it, translate it, scale it or skew it. It's totally up to you. And then basically apply the styles, right? Uh, by the way, I think I forgot one small thing. Scaling. I think scaling can be done in both X and Y direction. Where is the scaling? Yeah, I think I forgot this. Oh, come on. Okay. Okay. Let's say I want to have the scaling happen only in the X direction, not in Y direction. So I think I can say 4 comma 1, 4 comma 1, 4 comma 1, 4 comma 1, then 4 comma 1. Let's see. I don't know if you guys can make out. It is scaling in X direction only. Let me inspect element, go to main heading and turn on the hover state. Okay. In this I have scale 4 1, right? So if I want to change this to 4 comma 4, this is how both X and Y direction look like. But if you simply say 4 comma 1, then this is happening only in the X direction scaling, right? If you want to have only in the Y direction, then you will be saying like this. That is the Y scaling, Y direction scaling. So the syntax is X axis comma Y axis, and you simply say like this. Transform takes, let me say like this, X-axis pixel comma Y-axis pixel. Only transform takes pixels. Rotate takes direction, okay, plus and minus directions. And transform does not take, the scaling does not take pixels, okay. It simply takes a whole number. And then skew takes plus and minus in X-axis the directions, degrees. DEG means degrees. If you combine all this, you'll use matrix, and I am not good with its syntax. So the syntax of matrix is this. Syntax transform colon. It takes as scale X, meaning scale in X direction, then skew in Y direction, then skew in X direction, then scale Y direction, then translate in X direction, and then finally translate in Y direction. Why the syntax is like that, I don't know. This is how they have defined it. Okay, this is how they follow the syntax. The thing is, you will hardly see the matrix, because matrix is basically, you are moving in and you are also scaling it, and you're also stretching it all in one style. Most of the times you will not going to see this kind of behavior. Most of the time you're not going to see this kind of animation anywhere. You will either deal with moving or you will either deal with rotating, you will either deal with scaling or skewing, but it is highly unlikely that you'll be using all of them together. Clear, guys? Did you guys understand this animation? 2D animation, 2D transform. అర్థమైందా? So this is how we do the 2D animation. Next is 3D animations, and we will look into that. Like 2D animations happens only in 2 directions, whereas 3 dimensions will happen in the z directions also, right? So we will look into 3D animations tomorrow. 3D transforms, they kind of follow the same thing, but we have the option to specify which particular axis we need to make the transformation. You know what, let me complete it in 5 minutes. Okay, that is, so up until now we dealt with simply translate. So let's look into 3D animations real quick. 3D animations in CSS world. In CSS world, it is called as 3D transform. Okay. Again, same rules apply. Translate, rotate, and this. So I'm say same actions like 2D transform apply here, but we can specify which axis to use. Okay, and what I mean by that is we can use translate X, translate Y, or translate Z directions. Okay, let's quickly look into that. But translating is, okay, where is that? Translating in Z direction, right? Translating in Z directions, it is similar to doing in the Z axis, right? I mean, it's similar to Z index, right? So similarly, we can deal with rotating in X direction, we rotate in Y direction, and then we rotate in Z directions. Scale in X direction, scale in Y direction, and scale in Z direction, right? Then skew. Now skew is something that browsers at the time being, they hesitate to support that because stretching in Z direction is kind of not possible, because if I stretch it in Z direction, you will end up getting a dot, because stretching, how should I say it? When you're stretching um, when you're stretching it in X direction and Y direction, when you are stretching in X direction and Y direction, what happens is, if I keep on stretching it in the X direction only, chances are I'll end up with a single line after a point, because I have stretched it so much that I'm going to get a big line, just one big line like this. Similarly, if I stretch in Y direction, I'll end up having a one big line like this, because I've stretched it so much that everything comes to one single line. Let me show you that. Hold on. Let me, you know what? Let me try this. Take this guy out, then take this guy out, and then take this guy out, take this guy out, take this guy out, take this guy out, and then okay, let's say I want to stretch it in only in X direction, and I have stretched it in like 720 degrees. That is a big number, right? And then 0, and then copy this guy. Okay, so I'm stretching in X direction. Okay, I'm stretching in X direction with a big degree. What the heck? Skew. Hold on. Oh, there you go. This guy. Okay. I have stretched it so much that I ended up with almost a single line. If I increase more, if I go 630 degrees, I don't even see the element because I have stretched it so much that I can't even see that element, right? But if I reduce it, then I'll be able to see it. So let's say I have zeroed it out in X direction, X degree, but I changed the same in Y. If I stretched it so much, I'll ended up getting a single line, and after that the element is not going to render, right? Now if I want to do the same skewing in Z direction, I'll end up getting a dot, or the element is not going to get rendered at all, right? So there is no point of skewing in Z direction because I will not be able to see that element in Z direction. So that's why skewing skew in Z axis is not possible. We might not even see the element if even for 1 degree or even for 0.1 degree, because it will end up um, giving us a dot, and then you'll not able to see that. So that's why you will not see skewing in Z direction. So that's why you don't see that skew concept in 3D transform. You'll not see skewing here at all. Okay, you'll see rotate, you will see the scale, or you will see the translate, right? And to combine all three together, it is translate 3D, translate 3D, and then of course the X value, the Y value, and the Z value. Next is the rotate 3D, the X value, the Y value, and the Z value. And finally we got the scaling in 3D. We got the X value, Y value, Z value. That's all it is. The difference between 2D transformations and 3D transformations. Matrix is, of course, matrix combines all of them. Matrix 3D, it combines all of them. So it is going to take the scaling first. Scaling, it's going to take the scaling in X direction, then Y direction, then Z directions, right? And then it is going to take the rotate, rotate in X direction, Y direction and Z directions. Then finally we'll have the translations. Translation in X, Y and Z. Remember guys, in matrix the scale is given the highest priority, then the rotate is given the next priority, and then finally the translation is given the last priority. So this is how the matrix works. CSS transformation. Like more else, let me say CSS 2D and 3D transform. Clear guys? This is how we do it in 3D. Just we can add the third dimension, which is the z-axis, and then it is going to work. Let's quickly check out one small example here. So go back. Let me do it in 3D translation. Okay, and then take this guy out, take this guy out, take this guy out, this guy out, and this guy out. Now if I simply say translate, browser engine will interpret it as 2 dimensions. I need to say 3D, 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 and then 3D. Now I have to specify 3 dimensions. Now I have to specify in z-axis. In z-axis I want to make it by 30 pixels. Okay, I want to rotate it, I want to move it 30 pixels in z direction. I don't know if you guys will be able to see that, because let's see how it will react to it. It moves down, but it comes out. How should I say it? Let me power this guy up. It is coming in out in z direction, but the header, this navigation, has a z index here, which is a bigger number, right? So inspect element, this hover guy, if I increase, where is that? Translate 3D, if I increase this by, I don't know, a bigger number like 1000 pixels for example. I don't know, I have no idea if this will work. It's not working. But it is moving it in the Z direction. You're just not able to see it. That is the translation. Let me change this to, let me rotate it in 3D so that you guys will get a good idea. This IntelliJ adds this nonsense extra. Okay, now translate in 3 dimension, in 3 dimension, in 3 dimension, and 3 dimensions, and 3 dimensions. Now I want to rotate in 60 degrees in the x-axis, right? Right now it says rotate in the right. It is not going to accept it because I need to mention the 3 dimensions, and the syntax is simply rotate it in either in y-axis or z-axis, and if I'm using 3D, then I need to say x, y, z with the degree angle, right? So I'm going to say like this, 60 degrees, comma 0 degree, comma 0 degree, because I just want to rotate it for now in only in X direction. Okay, it is taking it. Okay, it did not take the style. That means my syntax is incorrect. So let me change this to 60 in X, 0 in Y, 0 in Y, and then like this. See if the syntax is correct. It's been so long that I have used it. Maybe I forgot the syntax. Let's see. Nope, I forgot the syntax. I forgot the syntax. Hold on. Rotate 3D CSS. Let's see. Rotate value XYZ and then angle. Okay. Yeah. Yeah. I forgot the syntax as I said. So this is not right actually. So it is actually X value, Y value, and then actual degrees. Meaning, if I want to rotate in X direction, let me say this. If I want to rotate in X, then the value is going to be rotate 3D, and then I'll be saying X as 1, remaining as 0, and then how much degrees is 60 degree in this case. So that is the syntax. If I want to rotate in Y, then I'll zero out this X direction. I'll simply say Y has to be one direction, and then it will rotate like this. Let me show you that in action actually. So this is going to be 1 by 60 degrees. So this means rotate in X direction, no rotation in Y directions, and no rotations in Z direction, and the value is 60 degrees. So let me refresh. I don't know if you can see it. It is rotating like now, right? If I change and say like, I want to rotate in both X and Y direction, then I need to set 1 and 1 on both X and Y, and then if I rotate, it is going to rotate both in X and Y direction. Finally, if you want to rotate in Z direction also, then I'll simply say 1 1 1 on all the three, and I don't know if you can make out, but it is rotating in Z direction. Okay, let me change this to 90 degrees. It will be easier for us to understand. It is rotating in both, in all the three directions. Let me do one thing. Let me zero out and then simply do it in the Z direction. It is kind of coming outwards for us, meaning outward in the sense like, if I go here, it is going 90 degrees in the Z axis, but for us to understand, the browser is rotating it in the y direction. You are not able to get it, but that is how the browser engine is interpreting it in. Clear? Change this to 0, change this to 1, and then run it. Different browsers behave differently. Rotate 3D here is saying, like, in Z direction, I want to rotate in 60 degrees, and it is rotating like this, and the browser is interpreting, okay, the Z axis rotation is going to be like this. Clear, guys? You can also say, like, if I want to increase it, like, in Y direction and have a custom axis, like how much value you want to have it in your X, Y, and Z directions. Like, for example, in this case, the Z has only one value. If I keep on increasing it and then add a Y rotation and then finally have a Z rotation, then you can create your own custom animation, custom axis. Like this guy, rotate in X, like I want to have a value in rotating in X, right? And then use Y-axis 2 times, and then negative Z direction means inwards, meaning inside the what do you call it, to the screen. And when it does that, the foo looks like this originally, and then the inward style is going to show up like this. So the value is the values here is totally up to us. How do you want to deal with it? But you have the power to basically deal with all the 3 axes and rotate it with a degree value. This is the only difference between 2D and 3D animation. Transformation, not animation. Transformations. Right? Any questions?
Hey Shrikar, I have a question. Like in interview, if they are asking me, like, have you done any animations? Like, have you worked on your projects previously? And what should I answer?
Yeah, I have dealt with animations. See, I'm
Like,
not done with the whole animations concept. This is only one part of the animation. There are more to come. So when I'm done with those concepts also, I'll answer your question. I cannot answer right
oh,
now
okay,
that answer.
okay, okay. I thought this is the only thing. Okay,
No,
yeah,
this is not the only thing.
sounds
There
good.
are others. There are others.
Oh, okay, okay. Thank you.
Yeah. Clear, guys? Did you understand the difference between 2D and 3D animation? Transform, not animation. Let me keep it as transform because you guys will get confused. Let me change this to 3D transform. 3D transform. Don't go with animation because moving forward you guys will get confused. So keep it with 2D transform. Okay? Did you guys understand the transform now? Does anyone have any questions at this point? Okay, tomorrow we are going to look into further concepts of animations, and we are going to dig deep into nice and clean animation and transitions and other sort of cool features that are available for us. Okay, if no one has any questions, then that's the end of the class. We'll meet tomorrow and we will cover more concepts. Okay. Okay, guys. See you tomorrow. Bye bye.